Hi, in this video we're going to be showing angles that are congruent. The first pair that we're going to look at are these things, vertical angles. So in our diagram right here, angle 1 and angle 2 are both vertical angles, and they should be congruent because they make that cool little X thing. There's another pair of vertical angles, so these are also vertical angles. If we look at these two blue guys on either side, they are another pair of vertical angles, and they're also congruent. What that allows us to do is solve little equations like we got going on in here. Since these two parts of our diagram are congruent, we can say 3x plus 7 equals 5x minus 27. So we can say this bit equals that bit. I don't know anything about this angle over here, but I do know that whatever this guy is, it's got to be the same as this guy down there. So since we've got that set up, let's just go ahead and solve that so we can figure out what the value of that variable is, because that's one of the directions, determine the value of the variable. So I'm going to subtract 3x from both sides here so I can get the x's together. So 5x minus 3x is going to be 2x minus 27. Let's kick this 27 over to the other side. So add a 27 to both sides. 7 plus 27, that's 34, equals 2x. And our last thing that we got to do is we got to divide both sides by 2. So 17 is going to equal x. Cool, we found the value of our first variable. Next, we've got these two angles that are right next to each other. These two angles form a line. So that line has got to be 180 degrees. They're also supplementary angles. So we could also say, hey, if we add those two bits together, it should equal 180. We'd have the same thing if we went off of this line, but I want to make another equation so I can make that y. And so I'm going to use these two. I could have used these two. So we've got 180 equals this 2x plus 8y, 2x plus 8y, plus this 5x minus 27, 5x minus 27. Now, we just solved for x, so we know what x is, so let's go ahead and put that in. So that's 17, 17. I wouldn't have been able to solve this earlier if it weren't for that 17, because there's just too many variables in this equation here. So it's a good thing that we got that x first, right? So plus 8y plus 5. So I'm just copying the equation, 27. So now I just need to simplify that down. I'm going to do 2 times 17 plus 5 times 17 minus 27. I'm just going to do a little cut here and put that in my calculator. So all these things together ends up being 92. And then we still got our plus 8y equals 180. Okay, that's a neater equation that I should be able to solve. So I'll go ahead and solve that. So I'm going to subtract a 92, trying to get that 8y by itself. So that's 88 equals 8y. And then we're going to divide both sides by 8. So 11 equals y. Cool. Now we know what x is and we know what y is. So they want us to figure out what the measure of all three of these angles are. So we just got to plug them in. Now, fortunately, these two are the same. So I could do either one. I'm going to do this one. So this angle here is 3 times our 17 that we got from over here, plus 7. 3 times 17 plus 7. Putting that in my calculator, I got 58. So this angle is 58 degrees. And this angle over here should also be 58 degrees. Great. Now I know that this last set makes 180, so I could take that 58 and subtract it from 180, but I'm also going to just kind of like double check it by plugging in our values. 2 times 17 plus 8 times our 11, which makes sense because if we add these two together, we get 180 degrees. So these are our two angle measures. These are our two values, And we're done. Well, the variables that we solved for, not values. Next, we're going to take a look at two theorems that are pretty similar, the congruent supplements and congruent complements. I've got the supplements version up here. The idea is that if 1 and 2 are supplementary, these two make 180, and 1 and 3 are supplementary, then hey, these two should be the same. We're going to prove this with complements down here. So the idea is we're going to start with a diagram. So I need to we are given that 1 and 2 are complementary and 3 and 2 are complementary. So I want just like a little 2, and then there's going to be this big 1. And then if we've got another little 2, and this, so these 2's are the same, and then a big 3. We want to show that these two are about the same. And they kind of look about the same, but that's also because I drew them that way. But they are definitely the same. So we're given that 1 and 2 are complementary. Those make 90. These two make 90. If 1 and 2 are complementary and 3 and 2 are complementary, then the measure of angle 2 is 90. 1, 2, and 3 is 90 using the definition of, we've just been saying it over and over again, complementary. Because all we know right now is that they are complementary. Then, so we got these two equations that they equal 90. Hey, if these both equal 90, we could kind of combine them that this has got to equal that because they both equal the same thing. So this is using our transitive property. You could also say substitution. We could say that since this equals 90, we could substitute this right where that 90 is, or the other way around. We're kind of substituting that in there. But the idea is that we're trying to connect those two statements together. In this next one, we've got this, but suddenly there's no more 2's. Where did the measure of angle 2's go? We got rid of them. And we got rid of them because those are values. The measure of angle 2 is some value, say it's like 10. We could kind of like subtract 10 from both sides and we would just have the 1 and the 3. So we are using the subtraction property. And since we did it to both sides of the equation, that's the subtraction property of equality. When you do something to both sides, it's always of equality. Finally, we want to say that, hey, the measure of angle 1 equals the measure of angle 3. Hey, if the measure of those angles are the same, they've got to be congruent, and they've got to be congruent using the definition of congruence. U-E-N-C-E. Because things have the same value, then they are congruent. In this example, we're looking for pairs of congruent angles in the figure. So we're going to use proper notation, but we're going to justify why later. But to start, let's just start with what we know about these little right angle guys down here. So if we start up here at GBE, we know angle GBE and EBH, they kind of come together to make one big 90-degree angle. So we know that those two are complementary because they make a 90-degree angle. So that was this one and this one. We also know that there's another pair right here with this angle and this angle. So those two make another 90-degree angle. It's a little crooked, but it is definitely still there. So we know that, and here I'm going to keep EBH in the same spot, but then we got this other guy down here, HBN, angle HBN are also complementary. Since we just used it, we're going to definitely use 3-3. Hey, these two blue angles are complementary. These are complementary. And hey, here's that overlap, kind of like our 2 overlap was in that proof. So by theorem 3-3, or you could just say the congruent complements theorem. We can say that these two angles have to be congruent because they're both complementary to this guy right here. Angle GBE and angle HBN are congruent. So that's one of our pairs. The other pair is something that's a little bit more obvious, uh, but it's this idea that we've got these two right angles right in there. And if those are both 90-degree angles, they've got to be congruent to each other because they have the same value. This is a theorem that we're going to prove in just a second here of since uh, angle EBN and angle GBH are both 90 degrees. They are congruent. And we're going to prove it in a second. It is theorem 3-4. And you could also say it by the thing we're about to see, where all right angles are congruent. So let's prove that now. So this proof is going to be a lot more straightforward than the one we just did, and that's okay. Really, all we're trying to practice is this idea of like writing a proof and then being able to back up our reasonings with these reasons in these blanks. So we start with a diagram. We are given that angle B and E are right angles. So if B and E are right angles, then the measure of angle B is 90 degrees, and the measure of angle E is also 90 degrees. We know these are both 90, using the definition of right angles, because we've just been talking about right angles. So if the measure of angle B and the measure of angle E both equal 90, hey, they both are equal to each other. So this is again using that substitution or transitive property. You can kind of like substitute this E where that 90 is, or you can say, hey, this is the same, this is the same. So this is the transitive property. Kind of got three ideas, B, E, and 90, and we're left with just two of the middle guys. Um, hey, those are equal. If those are equal, oh, that should be a B. If those are equal, then they are congruent using the definition of congruence. Done. That's proved. Much more straightforward, as I promised. Last quick example here, angle A is twice as large as its complement B. We want to determine the measure of each angle. So again, that idea of complement is telling us 90 degrees. So the measure of angle A needs to be twice as big as the measure of angle B. So we want these two to be equal to each other. We better multiply B by 2 so that they're going to be this. We also know if we add these two things together, we're going to get 90 degrees. So the measure of angle A plus the measure of angle B equals 90. We can kind of combine these two equations together, saying, oh, if the measure of angle A is two of these, we could put it right there. 2 measure of angle B's plus the measure of angle B should equal 90 degrees. See how I just kind of took this measure of angle A and put this right there. So 2 measure of angle B's plus a measure of angle B is 3 measures of angle B equals 90. We can divide both sides by 3, and we know that the measure of angle B equals 30 degrees. So that must mean the measure of angle A has got to be twice as big, which is 60 degrees. And that's it for our video on proving angles as congruent. Reminder with these proofs that you want to make sure that you've got good reasons for what's going on here. There's kind of like a bank of things that we'll be building up. That idea of complements and supplements are allowing us to get 90 or 180 degrees, and vertical angles, that's where we started, vertical angles are congruent. Thanks for watching. Goodbye.